So I've just received this little box here, which is supposed to contain a so-called quantum pendant, which is Japanese technology by quantum science, which says optimum energy for peak performance. Let's look inside. And you can see inside is this little pendant. It's pretty simple. It's just a silver frame with something gray here. And it's supposed to give you a lot of health benefits. If you wear it around your neck, it's supposed to give you energy and unclump your cells, whatever unclumping cells is. That sounds like a stupid hoax, but well, let's see what it is anyway, because the actual website that sells this claims that this thing has over 9,000 iron power. Also, on the back there are these strange stones that you can see here. One is supposed to be fur, whatever, which stands for far infrared. Doesn't make any sense at all. One is supposed to be anion, well, negatively charged ion. Does not make any sense either. And one is supposed to be germanium. Germanium is hella expensive, and this thing was like, I don't know, $15 or so. 15 US dollars. So what the heck is up with this? Take it out of the box. All the videos about this pendant I could find on YouTube seem to be some kind of advertising for an esoteric kind of pendant, like, you know, magic. But I am definitely more curious about this iron power. So let's see. This is the good old CDV 700 for simplicity, which has a pancake probe just hooked up to it. You can see it's a large pancake window, Geiger millitube. And it will let through alpha radiation. That's pretty much a thing. It will measure alpha, beta, and gamma radiation. Now let's turn it on. Just get a background reading. The pendant just, well, a little bit away from it. And you can see we have less than 100 counts per minute at all times. So now let's put the pendant in the same position, preferably. And then just put the probe over it. Whoops. Well, I guess that thing is radioactive. Try holding it directly onto the pancake. Put it on with the other side with those stones. About the same reading, I guess. This thing is supposed to contain scalar energy. Now, a scalar in physics is something that has only magnitude and not direction, so it only has a unit. For example, you could say mass is a scalar or energy is a scalar, but well, you know, it's kind of weird calling something scalar energy. It's like saying you have an LCD display, which means you have a liquid crystal display. This looks like another piece of magic bullshit. If you believe in it, it might give you a placebo effect, which may lead to you believing that this stuff works, but, well. So, from what I could find on the internet, this thing is pretty much just volcanic ash pressed into shape of this little pendant, and it seems to contain some radioactive elements. Now, those may be natural elements, which would be expected, or they might be, well, man-made elements, man-made isotopes, maybe stuff from Fukushima, who knows. Only the gamma spectrometer can tell us, so we should look at that. Alright, so I just performed energy calibration on the gamma spectrometer. The peak you can see here is from americium-241. That one is from cesium-137, and those two belong to cobalt-60. I'm using a gamma spectacular for power supply from USB, a simple USB sound card, and a large sodium iodide scintillator, which can just be seen here, which is embedded in about 50 kilograms of lead for shielding. Start again. This will take a while until it looks like a spectrum, especially as now. It's quite a low count rate, which is just a couple of pulses from actual radiation because the detector is very well shielded. There's some noise in it as well, which is not too bad if the count rate is high enough to be much larger than that noise. But let's also hear what the spectrometer says, because this latest version of Pulse Recorder and Analyzer by Marek Dolizer, which is free, now allows you to hear the pulses by the pulse height, which will be a tone height. So that's what the empty spectrometer sounds like. It's rather hard to do with the camera in hand, but... So yes, the count rate went up, not too much, but it did go up. So we'll just have to wait and see what happens within a long, long time. So after a while we've got quite a messy spectrum, as it seems to contain quite a lot of photopeaks. This one could be assumed to be a lead X-ray. Just in this area of the next peak there could be radium, and so on and so on. This could be bismuth, for example. So the point I'm trying to make is this is most likely naturally occurring radioactive material. For example, uranium ore or thorium ore, or a mix of the two. So I guess due to the many photon energies in here, it is best to analyze this little thing by high purity germanium spectroscopy, which has a very good energy resolution and will allow us to tell apart the individual peaks that make up this huge messy spectrum here on the sodium iodide spectrometer. And maybe I can also perform EDX, energy dispersive X-ray spectroscopy, and see what kind of non-radioactive elements are in here by putting it in an electron microscope. So, well, that's a project for the next weeks, I guess. Stay tuned for the results.